Hello everyone, this is Prasad. On behalf of Unacademy, I welcome all of you for another amazing session on hybrid electric vehicle. In previous session, we have understood what are different types of charging methodologies for electric vehicle. We have understood that most of the electric vehicle are using CC and CV charging, that is constant current, constant voltage charging. And we have also understood different types like what can be battery swapping, what can be pantograph charging, what can be cable based charging, or what can be wireless charging. Now, in this session, we are going to go ahead and understand in detail further things about electric vehicle charging and onboard chargers. So let's start today's session. So let's understand first of all what is an onboard charger. In previous lecture, we have understood that you can either charge your electric vehicle with a AC or a DC. And we have also understood that whenever it is DC charging, there is feasibility of charging your electric vehicle fastly. So if you want to charge the electric vehicle fast, that is called as fast charging, you can use DC source for the electricity. Now, when you are having a fast charging facility, of course, it is not on board, it is off board. It is outside the vehicle. Okay, so DC charging feasibility is only with off board charger. Now, when we are discussing onboard charger, what exactly it is, let's understand. So onboard chargers are power electronic devices that facilitate the charging of high voltage battery in the EV from AC grid. So most of the times it happens that we are having the supply of electricity that is in the form of AC. All of us know across the world we are using alternating current for generation, transmission and distribution of electrical energy. So when you consider the alternating current to be source for charging your electric vehicle, of course you have to have some mechanism that will convert this alternating current into direct current because the batteries are working on DC. So you have to have some power electronics involved that will convert this AC into DC. And this AC into DC is called as rectification. This is called as rectification. So rectification is done by the onboard charger. So onboard chargers are power electronic devices that facilitate the charging of high voltage battery from AC grid. The controls are done by this onboard charger, and the current and voltage are controlled which the battery needs to be charged. Okay, so we have understood that we are having CCCV charging, that is constant current constant voltage charging, wherein from 0 to 100% constant current charging is done, and from 0 to 80% constant current charging is done, and from 80% to 100% constant voltage charging is done. So this all is to be understood by onboard charger. You have to program the onboard charger in such a way that when you are doing CCCV charging, for initial 80%, it will make sure that it is giving or feeding the constant current to the high voltage battery, and from 80% to 100%, it is feeding constant voltage to the battery. So it is very much important to maintain the lifespan, the state of health of the battery, and onboard chargers are very vital considering the slow charging of electric vehicles. Okay, so general requirements are what for onboard charger? First of all, it should be complying with the requirements of the grid in the location where it is to be used. For example, if I erase this and if I quickly tell you, in case of electrical energy utilization, there are two kinds of voltages. Like if you consider India, in India we are having 50 hertz as a frequency, and standard AC voltage for single phase is 230 volt, and for three phase it is either 415 volt or 440 volt. But in America the standard is different, it is 60 hertz at 120 volt for single phase. So we have to understand that onboard chargers should be capable of supplying this required demand of electricity to the high voltage battery, but it should also make sure that it is operating on the given voltage and current that is provided by the electricity grid. Okay, so onboard charger must comply with the requirements of the grid in location where it will be used. Okay, so for India it is 50 hertz, it should be able to operate on 50 hertz, and if you are in US or in some other countries, the frequency over there is 60 hertz. Secondly, it should support both single phase and three phase. I told you 230 volt is a single phase voltage in India, and 415 volt or 440 volt is a three phase voltage. So it should be able to have both as an input, convert them into required DC output. So it has to also sense what battery needs, and it has to also know what AC grid is giving to it. So it should be capable of handling the supply of electricity in a proper way that will help the battery to get charged, and also it won't impact the lifespan of the battery. Also, it should comply with EMC standards. So electromagnetic radiations are very much dangerous for not only the human beings but also for the equipment surrounding. So it should follow the EMC standards, and if it is following that, then it is we can say it will be helpful for vehicle also, that is the equipment also, and also for the human being. Of course, it should have less weight, because if it is one of the factors that is going to affect the curb weight of the vehicle. I hope you know the curb weight. Curb weight means the weight excluding the rider or driver. So curb weight involves the weight of battery, very heavy battery weight involves a lot of what you can say percentage of curb weight. Then there is a motor, of course it is also heavy weight. Then there is transmission, but in case of electric vehicles, transmission is of very less weightage. But if you consider hybrid electric vehicle, then there is going to be IC engine, there is going to be fuel tank, there is going to be transmission involved, so the weight is going to get increased. But when we are considering only electric vehicle, the onboard charger can be one of the most important factors considering the curb weight of the vehicle. And we have understood in the second or third lecture that fuel consumption is proportional to curb weight. Okay, and across the globe we are focusing that we should reduce the fuel consumption, we should reduce the CO2 emission, and that's why we should reduce the curb weight. As per FAME 1 and FAME 2, I hope you remember this. As per FAME 1 and 2, we have understood that we are reducing the curb weight day by day, and we have understood the equation A into M plus B. I hope you remember. Fuel consumption is equal to A into M plus B. This is what we have understood. So curb weight is going to get affected by the weight of the onboard charger. So it should be as lightweight as possible, and of course it is of lighter weight comparing with the battery and the motor. Next, it should have good efficiency. I hope you know efficiency is output divided by input. So as the onboard charger, input is electricity grid, input is electricity grid which is in AC form. Okay, there is the onboard charger which is getting fed with this AC grid, and output that is providing is DC. So in case of efficiency of onboard charger, I would say it is output that is DC power divided by AC power. So efficiency of onboard charger should be, this factor should be more than 96%, and then only it will give maximum power output. Whatever power output it is getting as an input, out of that ideally it should be 100% efficient, but practically it is not feasible to have 100% efficiency. So it should at least deliver 96 to 97% of the output with the given input. So if I would say that input is suppose 100 kilowatt of power is the input, then output should be minimum 96 kilowatt. Okay, so its efficiency should be greater than 96%. Then it should be capable of doing both unidirectional and bidirectional power flow. Now a question may arise in your mind, so why bidirectional? Let's understand one amazing concept. I hope most of you don't know this because you don't belong to electrical engineering, but this is very interesting concept. Do you know solar photovoltaic? Okay, in solar photovoltaic, now the systems are becoming on-grid. What is on-grid system? On-grid system is the one which is connected to the utility grid. Means, for example, you are from Gujarat, for example. So you have installed suppose 2 kilowatt of solar photovoltaic system on your rooftop. You are having a bungalow over which we have installed a solar photovoltaic system. And what happens is most of the time your generation from this 2 kilowatt system is more than your requirement. Okay, so what you can do, whatever additional power has been generated, you can supply that power to the grid.